Today we're looking at evolution. Evolution is an idea that stretches back a very, very long time. It's a story that has an interesting list of characters, from Mary Anning, Alfred Russel Wallace to Charles Darwin. The story exploded with the publication of a single book, this one, on the origin of species. Evolution is a very interesting and a very big idea in science. It tries to throw a light on where we came from, why we are here, and the meaning of life, I guess. For that reason, some people say it is dangerous, it's controversial. It's an idea that should not be taught at schools. This topic is in two parts. The first part is geological time, fossils and evolution, and the second one is on Darwin, Wallace and natural selection. But let's start off with a few questions from last time. See if you can remember anything about competition. Number 1. What is competition? What is the difference between interspecific and intraspecific competition? What is the difference between specialists and generalists? What is a niche? What happens when niches overlap? Pause the film and see if you can remember any of those. Answers. Competition is when individuals have to fight for resources in order to survive. Intraspecific competition is between the same species. Interspecific competition is between different species. Specialists are species that have a narrow niche. Generalists have a broad niche. A niche is the position one species occupies within an ecosystem. When niches overlap, species have to compete more for resources. Geological time. Geological time is the sort of thing that if you think about it for too long, is liable to give you a headache. It is so long, it is virtually impossible to comprehend. The Earth is about 4,600 million years old. Fossils of anatomically modern humans date from the Middle Paleolithic, at about 200,000 years ago. But what does any of that mean? To help you put the age of the Earth in perspective, the 24-hour clock analogy may be helpful. If you think of all of Earth's history as having taken place in just one day, then the pie chart we just looked at is a 24-hour clock. So the Earth formed at midnight and cools down from a molten state over the next few hours. The oceans form and the asteroid bombardment diminishes. Very primitive single-celled life appears very quickly before 4 a.m. in the morning, and photosynthesis appears before 6 a.m. Around about noon, the atmosphere becomes oxygen rich. By 1 o'clock, the single-celled eukaryotes have arrived. By 5 p.m., the first multicellular forms appear. So we're at 5 o'clock at night now. The first aquatic animals don't arrive until after 8 p.m. Plants colonize land at 9:30 and land animals follow at 10 p.m. So we're now at 10 o'clock at night. The dinosaurs are the life of the party for about an hour, from 10:40 to 11:40. Human ancestors split off from the rest of the hominids at about 2 minutes to midnight, and modern humans arrive as the clock strikes midnight and the day is over. In terms of geological time, modern humans have literally just appeared. Looking back in time. Now, this is the Grand Canyon. The rocks at the top of the Grand Canyon, Arizona, are 250 million years old. Those at the bottom are 2 billion years old. Now, the Grand Canyon is an example of a rejuvenated river basin in a semi-arid area. What this means is that there's the Colorado River, which runs through the Grand Canyon, and it has done for a very long time. The land is gradually being pushed upwards. Why are people interested in it? Well, if the rocks at the top are 250 million years old, and those at the bottom are 2 billion years old, as you move downwards, you're moving backwards through time. The rocks are formed from sediments, and they may contain fossils. So as you go down, you're travelling backwards through time, and the fossils that you're collecting are from earlier and earlier on. So what are fossils? Fossils are the preserved remains, impressions or traces of animals, plants, other organisms that lived millions of years ago. Some fossils contain the mineralized remains of the organism. In other cases, the remains have been completely dissolved, and what is left is an impression, which may later fill with minerals to produce a cast of the organism. In general, this is how fossils form. Stage 1. Mud and sand falls to the seabed. As layers build up, heat and pressure convert the sediments to rock. Dead animals sink to the seafloor. The soft parts decomposed or are eaten away, leaving only the skeletons. The skeleton is buried by sediment and is gradually mineralized so it turns into stone. Over millions of years, more fossils are formed. Upper layers of rock contain more recent fossils. As the sea retreats, or the rock layers are pushed up, the rock becomes exposed to the elements. Erosion by wind, rain, earthquakes, human activity gradually erode the rock layers, exposing the fossils. Fossilization is a rare event. Different types of fossil form under different conditions and environments. So they can form from ice and frozen soil. So there was a case in Siberia where a mammoth which had been frozen in ice suddenly appeared. It was still relatively fresh. And what happened was the people ate it. That is a wasp, I think, which has been preserved in amber. Now, amber is a resin which comes out from trees. So what has happened, you've got an insect which has been caught in it, and then that resin has hardened into amber, and there's an insect which has been preserved. Tar pits. I'm not quite sure what tar pits are, but whilst I was looking this up, I came across this one. This is a rhinoceros which has been preserved in the tar pits. Fossilized remains only form in the absence of microbes, which need food, oxygen, water, and warmth. So when did living things first appear? 4,500 million years ago. It's known as the Hadean era. The Earth is formed sometime after the Big Bang. 3,000 million years ago is the Archean era. The Earth's atmosphere is composed of methane, ammonia, and other gases too toxic to support life. However, as the Earth crust cools, oxygen-producing bacteria and single-celled organisms develop. 1,500 million years ago. This is the Proterozoic era. Sedimentary rocks form, and as oxygen levels rise in the atmosphere, the first multi-celled organisms such as primitive sponges and trilobites evolve. 350 million years ago, this is the Paleozoic era. Oceans have begun to form, and primitive land plants such as ferns appear. Invertebrates and hard-shelled marine animals later develop, followed by winged insects and early reptiles. 175 million years ago, this is the Mesozoic era. Dinosaurs, mammals, early birds, and large crocodile-like reptiles appear. Fish and flowering plants have also developed. 50 million years ago, the Cenozoic era. Dinosaurs have become extinct, but modern birds and large mammals have appeared. Later, Stone Age humans hunt animals such as the woolly mammoth and woolly rhinoceros to extinction. And today, the Pliocene or the Holocene. Early humans become fully modern. The Ice Age ends and modern civilization begins. Today, over 10,000 animal species are in danger of becoming extinct, mainly as a result of overhunting and loss of habitat, carried out by one species. That's us. Now, the history of life on Earth as shown by fossils is called the fossil record. Although there are gaps in the fossil record, it helps to tell the evolutionary story of past and present-day organisms. It can show how the changes in an organism were linked to changes in its habitat. The fossil record can also show how different species evolved from common ancestors. Gradual changes in fossil records. Now, a classic example of this is how the horse evolved. First horse, Hyracotherium. It was about the size of a dog. It got 4 toes. 40 million years ago, the Mesohippus. It's a little bit bigger, still got 4 toes. Still lives on grass and leaves. 17 million years ago, the Merychippus. Bigger, it's got 3 toes this time, and its diet is grasses, and it lives on grassland. 12 million years ago, Pliohippus. 1.2 meters, 3 toes. 4 million years ago, Equus, the modern horse. About 1.6 meters, it's got 1 toe, lives on grasses. So how did the horse evolve? Early ancestors of the horse ate soft plants and leaves and lived in forests. As the forests shrank and grasses evolved, so the horse's ancestors evolved in response. Their teeth became longer and evolved flatter, grinding surfaces and a covering of hard cement to be better adapted to chewing tough grasses. They became larger, longer-legged, and moved on tiptoes to be better adapted to fast running on open, plain grassland. This is Mary Anning. Mary Anning was an English fossil collector, dealer, and paleontologist who became known around the world for important finds she made in Jurassic marine fossil beds in the cliffs along the English Channel at Lyme Regis in the county of Dorset in southwest England. Her findings contributed to important changes in scientific thinking about prehistoric life and the history of the Earth. A paleontologist is somebody who studies fossils. Her discoveries included the first correctly identified ichthyosaur skeleton, the first two nearly completed plesiosaur skeletons, the first pterosaur skeletons located outside of Germany, and important fish fossils. She struggled financially for much of her life. Her family were poor, and her father died when she was only 11. However, despite this, she became well known in geological circles in Britain, Europe, and America, and was consulted on issues of anatomy as well as about collecting fossils. Nonetheless, as a woman, she was not eligible to join the Geological Society of London. In 2010, 163 years after her death, the Royal Society included Anning in a list of the 10 British women who have most influenced the history of science. Evolution. Now you have most of the background information. In recent lessons, we've learnt about adaptation and competition. We've looked at ecology and how communities of species interact with each other and their habitats. And now we have some understanding of geological time and the fossil record. It's now time to look at evolution and join up the dots. If you look back through geological time, the fossil records show that life has progressed from very simple forms to the complex plants and animals we have today. Some animals, such as the shark, has remained unchanged for the last 450 million years. Other animals, such as the dinosaurs, were all wiped out millions of years ago. Human beings are now the dominant species on the planet. But how has this happened? And how does evolution work?